This is James Gaspard, and this is the story of biochar. Biochar is an extremely exciting product. This product has many uses in our current need to address climate change. It also has uses to remediate the soil. It has uses in carbon sequestration. It binds water. It can help restore arid parts of our country to grow vegetation. Just many incredible uses. Now, biochar is thousands of years old. We will now hear from Dr. Johann Lehmann, a professor at Cornell University and the chairman of the International Biochar Initiative.
Dr. Johannes Lehmann of Cornell University is one of the top researchers in this field.
A Cornell professor, the first professor in the Department of Geology in the 1870s, traveled to Brazil and came back with stories about terra preta, wonderfully fertile soils on the banks of the Rio Negro. Terra preta is the remnant of previous occupations of Amerindian populations starting at about 7,000 years before present up until the arrival of the Europeans. These soils are very dark, black soils that are very organic matter rich, very fertile, crops grow vigorously on them. So the exciting aspect of that is that in an environment that otherwise features very infertile soils under primary forest in the Amazon, there exist these very dark, very fertile soils that prevailed over hundreds to thousands of years up to present time. How biochar was created in the past to produce terra preta is of course largely unknown. One way how this could have happened is using technologies that we also know from charcoal making, piling up biomass and under the exclusion of oxygen, smoldering or thermally decomposing biomass into charcoal or biochar.
When you're Googling biochar and how to make biochar, you'll run across a word called pyrolysis. We are really not burning anything. It's a chemical reaction. Pyrolysis is basically heating up a wood or any organic matter in the absence of oxygen. It starts a chemical reaction. The chemical reaction goes to a lot higher temperature than regular fire. It's really just cracking the tars and the lignins and the water and everything out of the cellular structure of the organic matter, and converting the cellular structure of the organic matter into a pure carbon that has special properties that binds other molecules. Here's a comparison of two commercially available biochars. The biochar on the left, you will notice, is far more shinier than the biochar on the right. It's very important whenever you're properly preparing biochar to remove all the tars and the lignins from the finished product, as you don't know how that will react with the plants. It could even be toxic in the soil if it's not properly prepared. So the easy test is just to see if the biochar is shiny, which means the tars and the lignins and the oils have been cooked off. As you can see on the right, there's more oils and stuff on the face of the carbon. Another simple test would be just to simply hold it in your hand and see if anything stains your hand, which the oils on the poorly prepared biochar would stain your hand, and the properly prepared biochar, you'd be able just to wipe it off.
Agriculture is the most destructive human activity on the planet. Can we feed the world without destroying it? The difference between death and life, between extinction and abundance, is the difference between dirt and soil. Roughly 30 soccer fields worth of soil are lost every single minute. Today, 70% of our planet's soils have already been destroyed. At this rate, the Earth runs out of farmable soil in a mere 60 years.
Biochar improves soil in many different ways. It retains nutrients for plants that would otherwise be lost by leaching or to the atmosphere. It enhances microbiological activity, retains water, and increases crop yields.
A plot where we applied additional charcoal, yield is much bigger, so there is corn. And this is a plot where we applied charcoal and mineral fertilizer. And this combination, last harvest we had an increase in crop production of 880% in comparison to mineral fertilizer without charcoal.
In this part of the world, we have really poor soils. So our soils are basically decomposed granite and other just poor quality soils without a lot of organic matter in them. The biochar can be the foundation in the soil to create a living soil. Beyond just sequestering nutrients and releasing those to the plant, or sequestering water and releasing those to the plant, the biochar is a home for the microbial life that should be living in the soil here. So basically the biochar acts as a home for the microbes flourish, the microbes live and die, go through their life cycles, create nutrients, create a living soil themselves through their life cycle. That's the secret of the biochar in the regenerative ag world.
A healthy tablespoon of soil contains an astonishing 6 billion microorganisms. Tens of thousands of different species, each playing a vital role in the cosmic microbial ecosystem.
Hi, I'm Charlotte O'Brien, Director of BioBamboo. The reason biochar is so effective is because it has a very high surface area that allows microbes, particularly mycorrhiza, to live inside the biochar. It makes mycorrhiza flourish. Mycorrhiza is a microbe that grows in combination with 90% of all plants. It's a symbiotic relationship in which the plant over-photosynthesizes by 40 to 50% and exudes those carbohydrates down to the mycorrhiza. The mycorrhiza then go out into the soil and bring back nutrients that the plant would otherwise not be able to get. When there are drought conditions, mycorrhiza can go out and bring back water. But perhaps most importantly for climate change, mycorrhiza sequester carbon in the soil through a system of taking the carbohydrates given to it by the plant and turning it into glomalin, which is what gives soil that wonderful tilth, making more room for additional water to soak in when the rains are heavy rather than rolling down to the valley. So this glomalin is a form of carbohydrate in the soil. In soils that are farmed sustainably, it has been recorded as much as 32 tons of carbon dioxide have been sequestered per year per hectare. This is an essential part of our system.
Just a 2-inch piece of biochar, if unfolded, would have the surface area the size of a football field. This structure is an optimal breeding ground for beneficial soil microbes, holding both water and nutrients where plant roots need them most.
One industry that has benefited from properly prepared biochar is the mining industry. They've done tests on tailings piles, they've done tests on residuals in rivers and lakes and stuff, and the biochar is properly prepared, binds those toxins and keeps them from leaching out of the mine site and polluting the surrounding area. High-profile projects that have been done with biochar include mercury cleanup in the South River. There's a lot of projects currently undergoing Superfund sites where you're cleaning up copper, zinc, arsenic, a whole list of toxins, PCBs, dioxins, even PFAS. Properly produced biochar can bind PFAS, which is the latest forever chemical that's going to need a lot of remediation in the world. Properly prepared biochar has been used to stop major algae blooms in just a very, very short period of time. Not by killing the algae. They bind the excess nutrients, which causes the algae to be reduced. Properly prepared biochar has been used in lakes where they've been able to remove all the muck from the bottom of the lake as the cycle, basically the same way it built up by excess algae and building up the muck. As you remove the nutrients, the muck remineralizes into the water, and there have been lakes in Colorado cleaned up of 30 inches of muck off the bottom of the lake in a 2-year time period. So properly prepared biochar takes the nutrients out of the water bodies where they shouldn't be, the excess nutrients, and puts them back into the landscape and binds them up to where they don't wash back out into the water bodies and they're taken up by the plants. Properly prepared biochar will bind glyphosate and atrazine and the legacy pollutants that have been used in commercial farming. Properly prepared biochar is an essential part of the carbon strategy to restore the balance of our atmosphere and the carbon in the atmosphere and to draw down the carbon. We take the waste wood and we convert it into a pure carbon. So the carbon that was sequestered into a tree or to other waste wood products, basically if you leave it to rot in a landfill, it'll go back into a gaseous state and go into the atmosphere. What the properly prepared biochar will do is break that carbon cycle, sequester that carbon for thousands and thousands of years. In essence, drawing down the carbon out of the atmosphere.
CO2 is measured right here in Hawaii every month. It has been done since 1958. As you can see by the chart, we go up, up, up. We're increasing at a rate of about 2 parts per million every year. Right now at about 390 parts per million, heading towards 450 parts per million, which is considered the tipping point. That gives us 25 to 30 years to begin to resolve this problem. NASA's Goddard Institute has given us a mandate of drawing down 36.85 gigatons per year for 30 years to return the Earth to balance. That is an enormous amount of CO2. CO2 can only be drawn down by natural forces. There's no magic vacuum cleaner out there that's just going to pull it down for us. We must work in conjunction with nature. Doesn't matter how much we reduce our emissions, we still have to pull down what's there or global warming will continue to increase. The biobamboo system does just this by drawing down CO2 levels, environmental restoration, microclimate balancing, rural poverty alleviation, soil rejuvenation, reforestation with bamboo, new technology deployment, food security, erosion control, and bamboo as a building material. The question is, what would it take to make farmers in the tropics and subtropics spontaneously plant more bamboo on their marginal lands? And the answer is, give it a good market price. Tie it to the world economy. So what would tie bamboo to the world economy? Making it a designated biomass that replaces fossil fuels. And then of course people will plant it. So the system is this. The CO2 goes into the bamboo. It also goes into the ground under the bamboo. Some bamboos are nitrogen fixers, as well as the companion plants that are also nitrogen fixers. The bamboo is used as a biomass that goes into pyrolysis that produces electricity, thermal energy, bio-oil, and biochar. The biochar is put on agricultural fields that then increases their crop yield, and that additional increase goes into farmer retorts that make additional biochar, and that additional biochar goes onto additional farmer fields, so you have an exponential drawdown. The question is, who wants to do the work? Who will do the work to draw down carbon dioxide? Who will help nature do this for us? And the answer is, there happen to be about 3 billion people on the earth that are either unemployed or underemployed. I call it the bamboo culture of people that tread lightly upon the earth. They use infrastructure that's been put there by their ancestors. This is actually one of the best paying jobs in this entire region. It would help this area if some of the outside income from the world economy were to come into it. And this system of paying people to grow bamboo to draw down CO2 would help them stay in those villages where they want to stay with their families.
Biochar is an amazing product. What old is new again. They knew how to do this thousands and thousands of years ago to clean up their environment and to grow more food. All we have to do is go back to what was known thousands of years ago, and we can properly restore our climate. We can reduce the toxins we've emitted into this environment. We can grow more food, all naturally, all organically, all the way nature was meant to be. The biochar has properties that interacts with the plants since the beginning of time. Nature's been needing this product forever, and it's time for us to restore our earth.